Hi, I'm Gordon, and this is the fourth video in a series where we're taking a look at classifying text. Specifically, we're working with NHL scouting reports and classifying along the lines of whether the player is a forward or a defender. If you haven't seen the first three videos in this series, I very much recommend that you go back, as this video will not make much sense if you do not. So I didn't initially plan to do this fourth video, and what really got me thinking it would be worthwhile is the comparisons that we can make between what different types of models will get us working with this text data that we have. And I think this also will help illustrate a little bit about why in natural language processing attention mechanisms are so important. So I'm going to try to tie together a few different things. We're not going to be focusing a ton on code in this, and I will show all of the code that I'm using for this video. However, I'm not going to go line by line through everything like I've done in previous examples. And part of the reason for that is that the bulk of the code that I'm working with here is either the product of someone else's work. For instance, one of my instructors from my master's program, whose name was Donald Wedding, this code is directly copied from his work. Another reason is that if you don't have much of a background in machine learning or that sort of thing, this is going to be maybe a little bit more difficult to explain. But I will tell you a lot about the results that we're getting here. Okay, so what's the question we're specifically working with? We want to know, after we processed all of our text and we took this bag of words, threw it into a TF-IDF vectorizer, and then fed that to a neural network, which words had the greatest impact for our model to say this was a forward or this was a defender? That's a difficult question to answer when you're working with a neural network model, simply because of the complex relationships that can come up in a model like that, which might be capable of making the observation of, well, this word by itself typically means that this is a forward, but this word, when we find it in company with these several other words, actually usually indicates a defender. So those are complex relationships that are hard to untangle. What we're going to look at instead are some simpler models, specifically a decision tree, a random forests model, and then a logistic regression model. And we will pull from these what they think of the individual words. And I think, as you'll find, it's pretty informative, and I think it gives us a very good idea of how our more complex model most likely is pulling most of its information and how it's thinking. Okay, so a couple of quick imports here for tree, and then we need these functions to pull results from these various models. I'm not going to cover these in depth again. They're not even my code, but what we're doing is pulling results for them. This last one is for our logistic regression model specifically. And this is going to print out each word that occurs in our corpus, as well as a coefficient. That coefficient will impact, whether this model is more likely to classify as a forward or a defender. And once we see those, I'll talk a little bit more about them. This function is also going to put together a data frame for us, which will make this a little bit easier to interrogate. Okay, so after we put all of our functions together, let's just go ahead and build a decision tree classifier. It's going to take a look at the information we have and tell us whether these are forwards or defenders. It's always useful to look at different models and see how well they do, be able to compare them to each other. And with this one, we'll find it doesn't do quite as well, but it does a reasonably good job of identifying forward versus defender. Our neural network model, you'll remember, can get results up to the 97, even 98% classification accuracy. And the main deficiency of our decision tree model here is that it's not capable of getting the complex relationship that can occur between certain words. And it's always leaning toward classifying as a forward. That's what this one is right here. Indicates that we're classifying the player as a forward. Not very good recall statistics for its defenders. Okay. Our random forests model we're putting together right here. And this looks pretty good, right? A little bit more complex model structure. And we can see it's doing a much better job in both classes of identifying who's who. Now let's go ahead and just take a look at, since this model is doing pretty well, it's close and I've run this several times with different random states. Somewhere between 88 and maybe 92% is where this random forest model lands. And even with tweaks to the number of trees or that sort of thing, I haven't been able to get this model to exceed maybe 92%. So I'm guessing 93 is probably the highest that it's going to go for its accuracy. And if we want to take a look at the variables that, or in this case, the words that this model believes are important to classification, this is the code that we need in order to accomplish that. And this is going to take a minute to run. So while that's going, let's jump ahead just a little bit and get a look at some of the next lines of code here. We're also going to, because we want to look at what the logistic regression model is doing, we also want to go ahead and import from sklearn, logistic regression. And when we get into this model, when we're looking at the logistic regression, we're going to go ahead and print out a few different things. So this function, which you might remember I showed a moment ago, is going to print out every single word for us, but it's also going to put together a data frame that will make interrogating this much easier. The function itself pickles a data frame, which we will then go ahead and read in, and then we will sort to determine, both what's most likely to make this classification show forward versus what's most likely to show it as defender. Okay, so this has completed its run, it looks like. Let's take a look at the random forest variables. And what you're seeing are the words, and then how many of the random forest trees involved that word in their determination. So these words, this model is saying, are of no consequence. We don't even need to look at them. And as we scroll up here, and remember we have a lot of words, perhaps I should scroll faster. Now we're starting to see, okay, 1 out of the 100 for each of these words sees them as important. And that makes sense because a lot of these words don't seem particularly important to our question. Now we're getting into some of the more impactful words. Blue liner, that makes sense that we would start to see that. Defenseman. Some of these make less sense. Going, for instance, I'm not sure how that would have much of an impact. But then we're seeing winger, we're seeing talk about how a player defends, their skill, etc. And we get up here to the most important words. These make a ton of sense to us, right? The word defenseman, when it's singular, every single model saw that as important to the classification. The word defender, again, when it's singular, every single model saw that as important. Well, 38 of the 100 models saw that as important. Something that's a little bit more subtle that I find interesting is discussion of mobility being important. And as you'll see when we get down to the logistic model, the logistic regression model, I should say, these are indicating defenders, as is stops. Defenders plural is somewhat important, but not as important as defender singular. Defensive, outlet, defensively, playmaker, interesting stuff. Okay, and we'll move on. We need to go ahead and import for logistic regression. We'll build our model and print out the results. This model is really a lot closer to what our tree model did, although it looks like it's going about things in a different manner. You can see it's basically classifying everyone as a forward, is what it looks like. And yeah, that's indeed what it's doing. Less than 50% recall on the defensive class for our logistic regression model. So in that sense, this is the worst of the models that we're looking at. But let's just go ahead, and here again, we're printing out in alphabetical order every single word in our data set and how it impacts things. Now, I should also point out, which direction are these going? What is a positive number a good thing or a bad thing? Well, we have an intercept in here. I believe it's going to print out the intercept. And let's see. I've got 6,500 words in here. Let's see if we can get to the eyes. Getting close. Okay. And this is actually the word intercept, which does appear in our corpus. However, I believe there is an all caps intercept, which perhaps is not printing out here. We'll take a look at that in a second. Let's go ahead and look at the data frame, though. This is going to make things a little bit easier to determine. The long and short of it is, the higher the number, the more likely it's classifying as a forward. The lower the number, the more likely it's classifying as a defender. Okay. And the top words for forwards, we've got playmaker, defenders, plural. Isn't that fascinating? Defenders, plural, is showing up as a word that's very likely to indicate a forward. And the reason for that is when you go through all of these reports, you'll find often, sentences like the guy's got the ability to beat defenders down low, or the ability to blow by defenders, that kind of thing. And that's often indicating a forward. Other words that we would expect: forward, singular, center, scorer, winger. These make perfect sense. These words fit really, really well with the forward class. Let's expand this out a little bit, because I think the intercept I was talking about, here it is. All caps. The intercept that we start off with is an assumption. This is our baseline, right? That this is probably a forward. Okay. And now, if we want to take a look at which words indicate defender, here we go. Defenseman, singular. Defender, singular. And this is fascinating, the outsized impact of this one word. I'm guessing that this probably never, or maybe almost never, shows up in a report for a forward. Mobility is a little bit more subtle. I think we mentioned that. Talk of how they play defensively. Their defensive game might be what we're seeing there. The fact that they can get stops is something we'll often see. What their reads are coming out of the defensive zone, how they play in transition, outlet passes, outlets, positioning. This is a word that I actually replaced the word offensive with. So it is interesting to see it showing up here as a top word for defenders. But that, that makes some sense. And I replaced all of the words offense, offensive, and offensively actually for a different purpose, but that's something we'll get into in another video, is the sentiment analysis that I performed on this corpus. I found that the words offensive and offensively were confusing my pre-trained sentiment classifier. And that makes sense, right? Anyway, this is good enough. My last comments here will be that we have to pay attention to, why is it that certain certain reports get misclassified, right? And I'll show you the results from, this is from a run that I did. This is one of the better runs. In fact, 97% accuracy with my neural network. And I wanted to see which reports is it getting wrong. Well, really, fascinating to me, I don't want to show the whole thing, but let me scroll to it really quickly. Fascinating thing to me, here we go. This is just a piece from a single report that I will show. This comes from Scott Wheeler, and he writes at The Athletic. I'm just going to crop this slightly so that we get, this is work from Scott Wheeler's 2018 Top 100 Drafts, Draft Prospects. And I'm not showing the whole thing on purpose here. I don't want to show too much of these texts that do exist behind a paywall. Specifically saying this player is, he's more of a long-term project than other high-end defenders in the class. And he's also saying in another line here, let's see here, copy this over. Another line from the same report, he's got one of the better shots among the defensemen in the class. So, these are words that, depending on how you look at it, we said earlier, defenders, right? I'm gonna scroll back to what we had down here, and we want to look at this. Defenders was the second most popular word for forwards. And so, when we take a bag of words approach, and that's what we're doing here, we're saying order doesn't really make much of a difference, and it makes no difference at all for a tree model. I should clarify that. The way that our data is set up, it is possible for a neural network to see order as more important because all of our vectors are using order. But that's very unlikely for that to occur based on the very simple neural network structure that I built, and based on the fact that not every, well, actually, you know what? I take that back. That's not, based on the way that I constructed the data, our neural network would not be taking order into account either. Okay, I digress. But the main point here is that because order is not going to be a factor, and because we've taken a bag of words approach, there is no way for any model that we construct using this data to be able to understand that when he says defenders here, he's specifically telling us what class this guy, the subject of this sentence, belongs to. In order to get that level of intelligence out of your natural language processing model, you need something called an attention mechanism. And I'm going to stop this video here and not worry about diving into what that is. But I will just, I will throw out there the attention mechanism. What it does is it allows us to, this is a very simplistic way of describing this, but it allows us to gain a little bit of insight as to context when we are reading through text like this. Bag of words does not. All right, let's go ahead and end this video here. Thanks so much for listening.